Great to see you here. My name is Luc de Koster and welcome to this new video about samples, the sampling error and the central limit theorem. In this presentation I will talk about the central limit theorem. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So basically we looked at the central limit theorem, we looked at the theorem where we were looking at the sampling distributions of a population that was in fact like a normal distribution. So we have an average and a standard deviation. We can use those two parameters to describe the entire distribution. We took samples from this distribution, and basically we found a normal distribution with the average equal to the average of the population distribution, and the same for the standard deviation. We could find an adjusted standard deviation, which is the population standard deviation divided by the square root of the sample size. Now, when we have other types of distributions, population distributions like U-shaped, triangular, uniform, beta distribution, and all the other possibilities, we can see how we can apply the central limit theorem. And there are some rules that we can follow. And it's very interesting because whenever we have those sampling distributions, they transform after sufficient number of samples into a normal distribution. Now, when we look at samples of n observations taken from any population with an average mu and a standard deviation sigma, provided that the sample is sufficient large, typically larger than 30, the distribution of the sample means x will be approximately normal, with the mean equal to the population mean, and the standard deviation will be equal to the population standard deviation divided by the root square of the sample size. Now, larger samples approximate better the normal distribution. But basically what we can do in these conditions is that we can replace the distribution by a normal distribution, and that's very interesting when we're looking at other applications. Let's have a look at some practical applications here. We look at the population of damages incurred by customers. We are an insurance company, and we know that the average of those damages is 4,530 euro, and the standard deviation is 595 euro. Now, based on this, we can say we want to take a sample of size n is 100, and we have the sample parameters. So we find that the average is 4,525. It means we have a sampling error of 4,255 minus 4,530, which means minus 5 euro. So we're very close to the population average. And we want to know what the probability is to have a sample with a mean value smaller than 4,525 euro. Now we are going to use the central limit theorem to resolve this. First of all, from the central limit theorem, we know that the average of the distribution of the sample averages is equal to the population distribution, which is equal to 4,530, and the standard deviation of the same distribution, we find that it's the standard deviation of the population divided by the square root of the sample size. The sample size is 100, the standard deviation is 595, which gives us 59.5. Now, we can calculate the percentage using the normal distribution or using the z-value and determine the percentage in the standard normal table. So when we look at it, the standard deviation, we have the z-value, so we have x average minus mu divided by the adjusted standard deviation. So we find here 4,525 minus 4,530 divided by 59.5 gives us a value of minus 0.084. So it will be close to 50%, a little bit less than 50%. Now, when we look at this, we can apply also what we call a correction of the z-value. And when we have a sample value that exceeds 5% of the total population, amount, we have to adjust the Z value with a correction factor, which is the finite population correction factor. And the formula of Z then becomes equal to the Z value that we have, but we have to divide it by the square root of n minus n divided by n minus 1. So basically what we are going to do is to reduce the standard deviation, because we don't have an infinite population, we have a finite population, and basically we have to adjust the standard deviation for this population. So that's basically how we can use the central limit theorem in these different problems. It's a very interesting element that we can use. Like I said before, people are using it in quality when they are using, for example, the control charts when people are looking at production or processes and so on. So that was it for this presentation, for this video. Don't forget to click on the subscribe button, click on the bell button, and whenever we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in the next video. Bye bye.